Okay, here's video 2 in the series where I will go over Roman numerals 4 and 5 on rotations and enlargements, and I will go over everything here, every single piece, everything that you see on this outline. Rotations and enlargements are a bit tougher for students to handle. They should be pretty obvious to you as math majors at the college level, but you should really expect to spend a lot more time developing these ideas with the high schoolers that you'll be working with. So, okay, rotation. First off, qualitative feel for what a rotation is. A rotation requires a center of rotation and an angle of rotation. So I'm going to start just by illustrating this with a single point, P. Alright, so you see P is over here. And I'm going to use the origin, O, as the center of my rotation. And I will demonstrate various images of P for various angles of rotation. So basically, kind of the way a rotation works is, so P is my original point, O is my center of rotation. You can almost imagine that O is almost like the center of a circle, and P sort of defines the radius of the circle. And then, we can rotate to produce images. So for example, if I put, if I rotate this over to here, to this particular point, that would be a 90-degree rotation for P, okay, that ends up here. So if I were to rotate P 90 degrees using the origin as the center of rotation, then the image P prime would be located over here at -1, 3. So you'll notice that the image P prime is always the same distance away from the center of rotation as the object P is, and you can also kind of see how we sort of swept that through an angle of 90 degrees, or 90 degrees, what is that, counterclockwise, if you will, or anti-clockwise, as they say in Jamaica. They say anti-clockwise. If I were to do a 180-degree rotation, I would keep going further. So if I were to rotate, that's roughly here, ignore that, obviously that's close to 180. If I were to rotate the point P 180 degrees about the origin, the image P prime would be located over here at -1, -2, -3, -1. Okay? So, and this is kind of important to know, just like you guys are probably accustomed to, when we have anti-clockwise rotations, those are considered positive rotations. So right now, I'm rotating P in a positive direction. So this is positive 126-degree rotation, right? This is a positive 180-degree rotation. If I come over here, this is actually, where would it be? Right over here. This is actually a positive 270-degree rotation. Now I know my measure is saying 90, that's kind of a glitch of Sketchpad, but I rotated P through 270 degrees in the positive direction. Now we can also have negative rotations, right? If I rotate clockwise, that same 270-degree rotation that I just mentioned, it's the same as a negative 90-degree rotation, right? A negative rotation is when you're going in a clockwise direction. So this is negative 90 degrees, negative 180. Negative 270, which is the same as positive 90, right? So that is a distinction that they do make in the Jamaican curriculum, is positive and negative rotational angles, and also anti-clockwise and clockwise rotations is also some language that they will use at times. So I hope that's kind of intuitive, what is meant by rotating a point about a center of rotation and an angle of rotation. All right, now let's up the ante a little bit here, and let's rotate an entire shape. And I'm just going to kind of work through an example here. Now, I just showed you this dynamic thing where I'm dragging this point all over the place. Now, obviously, if you're working with graph paper and pencils and rulers and compasses and protractors, you can't do that. So I'm going to try my best to kind of model the process of rotating a shape as students would do it with the tools that they're going to have. So I'll do it with an example problem. Triangle PQR, which I have drawn over here, has vertices, etc. P prime, Q prime, R prime is the image produced when triangle PQR undergoes a rotation of -90 degrees with the origin as the center of rotation. Find the coordinates of the vertices of triangle P prime, Q prime, R prime. Okay, so if I'm a student now and using my pencil and my ruler and my compass and protractor and all this stuff, and I want to rotate this triangle, I'm going to do it one point at a time. Like, I might start by pulling out my ruler and kind of drawing a line from the center of rotation, which is the origin, over to P. And I'm going to give that a different color just so we can tell and I'm also going to show it dashed. Okay. All right. Now, my image, remember, so it's like, this is kind of like the center of my circle now. So I want to rotate P negative 90 degrees such that the image is the same distance away from O, but it's swept through an angle of negative 90 degrees. So P prime should be down here someplace. It might be helpful for a student to go ahead and pull out their compass at this point and maybe draw a circle or at least an arc, okay, because we know that P prime has to be located somewhere along this circle because, the image of P has to be the same distance away from O as P was, and we have to sweep it through a 90-degree rotation. So, if I'm a student right now, I'm thinking, okay, I want to go negative 90 degrees. That means I need to sweep it this way. I might pull out my protractor now and just go ahead and measure out a 90-degree angle that moves in this direction. Okay, now, just because I have experience, I know that these images are always going to end up on sort of lattice points, right? So I can kind of tell without actually measuring with the protractor that we're going to kind of end up down there. Clearly I've just swept out a negative 90-degree angle, right? So P prime has to be located right here. Oops, come on. Let me relabel this. This has to be my P prime. Okay. Swept it through a 90-degree negative angle. I'm going to go through the same process for my points P and my points Q and my points R. So, again, I'm going to pull out my ruler and I'm going to draw a line from the center out to Q, and I'm going to make this a different color as well. Let's make it red to distinguish it, okay? Now I know that Q prime needs to sweep 90 degrees in this direction. It's going to end up down here somewhere. So, and precisely, it's got to end up on this circle, which I need to color red so that we can see it a little bit better. Okay? So now I'm focusing on the red stuff. And I need to make a 90 degree in this direction. And again, I kind of cheat here. I see Q is located at what? 3, 3. So it's that, that's got to be a 90 degrees right there, right? At sort of 3, negative 3. You're going to find that that sort of the values of your x and y coordinates are going to kind of remain consistent. But you can see I've produced a 90-degree red angle right here. So this has to be my Q prime right over here. That's got to be my Q prime. Okay, hope all of this is making sense to you guys. Please ask me questions if it doesn't. And finally, I'm going to do a similar thing with R. So I'm going to draw a line from R to the origin. Let me just give it a different color so that we can see it a little bit better. How about purple? Going to draw a circle using O as the center and R as the radius because that's the distance that I want. I'm going to make this a purple circle. And now for purple, I need to form a 90-degree rotation. But again, I'm going to cheat here. I see that R is at 5, 4, so I know it's probably going to be at something like negative 4, negative 5. Yeah, see, that's right there on the circle. And sure enough, I can tell that I've made a 90-degree angle with my purple lines. So I've swept it negative 90 degrees. That has to be the location of my R prime. R prime. Alright, now let me connect. Did I screw this up? I'll soon find out if I screwed it up or not. Let's make that thick and let's make it black so that it comes through a little bit better. And now we're going to go like that, and we're going to go like that. No, I got it exactly right because I can tell clearly the yellow triangle rotated about 90 degrees to produce the black triangle. Okay, now I did that fast, and I bet you I even confused you with that. So you can imagine even high schoolers are going to struggle with this. You have the if you need to look at this over and over again, you certainly can. All right, but I'm going to go ahead and move on. Back up the video if you need to do it in slow motion. Now here's another tricky thing that those students are going to be expected to do. If you give them an object and its image, they need to find the center of rotation and the angle of rotation, which is kind of tricky. Now, I want to slowly build the rationale for the procedure that we do to do that, to find the center and angle of rotation when you're given the object and the image. It's somewhat intuitive if we focus on rotating one point onto another point. Okay, so imagine that you wanted to rotate this point P onto this image P prime. Okay, so it's almost like these are planets, right? Where's the sun? What sun is going to enable me to rotate this in a circle around until it hits here? And I think a pretty obvious point is going to be the midpoint between P and P primed, right? If you draw that midpoint between those points, it's pretty obvious that you can now construct a circle, okay, with the center at the midpoint, such that you can kind of rotate P around the circle and get over there to P prime. So you know for sure that the center point between 2 points will always work. Okay? Now here's something that's a little bit less obvious. There's actually infinitely many possible centers of rotation here. Okay? It turns out that, and I need to hide this one. Okay. If you take, sort of really any point along this line. Okay, do you see how that works? Like if I take a point here, basically the perpendicular bisector, I mean we already know that the midpoint has to work, okay? But it turns out that if we sort of run a perpendicular line relative to the segment that connects P and P prime, any point along this line is a possible center of rotation. So for example, this point over here could be the center of rotation because, again, I can draw a circle with the center over here such that that circle will sweep through both P and P prime. And really any point along this line, such a circle could be drawn. And even over here, right, I could draw a circle where this is the center, and sure enough, P and P prime would serve as points, would both be the same distance away. They'd be radiuses on this same circle. So to rotate one point onto another, the center of rotation could be any point along the perpendicular bisector of the segment connecting the object point and the image point. Okay, so that's kind of the key idea